Hello, everyone. In today's class, we are going to understand a very important concept in C++ programming, that is access specifiers. We're also going to explore the related ideas like friend functions and inline functions along with it, which play a key role in object-oriented programming. This topic is a foundation for encapsulation and data security in C++. So by end of this session, you will clearly understand how data hiding is achieved in C++ and how to control the access to your class members and also when to use the friend function or inline functions very effectively. Let's begin. In C++, access specifiers or the keywords that decide who can access what inside your class. They define the scope of accessibility of the class members, meaning whether data and functions can be accessed within the same class or outside the class or by derived class in case of inheritance. I'll repeat. Just we are going to check the scope of accessibility. That is, the data and the functions can be accessed in three different ways. That is, within the same class or outside the class or from the derived class in case if you're talking about inheritance. There are three primary access specifiers in C++, public, private, and protected. Let's understand why we even need this. When we design a class, we usually have some data. Example, let's take a student marks or an employer's salary that we don't want to be directly modified from outside. At the same time, we want certain operations like displaying the result or calculating the salary to be accessible. So we need a mechanism to hide sensitive data, but at the same time expose useful operations. And this is exactly what access specifiers do. So I can tell that they help in achieving encapsulation and data hiding, being one of the four pillars of OOPS, that is object-oriented programming, along with the other three are abstraction, inheritance, and polymorphism. Now let's begin with the first category, that's public access specifier. When we declare a member of a class as public, it means that it could be accessed from anywhere. As I said in the previous slide, it could be from inside the class or outside the class or through an object of the class or even by other functions. So public members have the widest level of accessibility. They are generally used to define the interface of the class, meaning the set of functions that other parts of the program can call. However, making these data members public breaks the principle of encapsulation because anyone can modify those variables directly, which could lead to data corruption or misuse. So here we have a sample code or small code to explain this. Let's begin the definition of the class named circle. A class group, the class here is circle. A class groups the data members and the functions that operate on the method. And you know that data means a member and can also call the functions as methods. So I could say that a class groups data or members and functions and methods that operate on that data. So here public we are given, public is an access specifier. Everything declared after this label until the other access label is given, it's accessible from outside the class. That's how via objects. So your data member of the type double that stores the circle's radius. Since it is under public, it could be read and written from outside the class. Example, if you give object.radius 5.5 Yeah, it could be accessible from outside the class. Yes. Now talking about a double compute area. So a member function named compute area that returns a double. It, it's defined inline inside the class body. So it's implicitly inline here. And return 3.4 radius multiplied by radius. So this calculates the area using the formula pi r squared. Coming to the main function, the program, actually this is the entry point for the program. The execution starts here. The function returns an int to the OS. Coming to the circle object, it declares a variable object of type circle. This calls the default constructor. That's the compiler generated one because none is defined explicitly. So object obj, it's an instance that's object allocated onto the stack. Object.radius is equal to 5.5. It's given, as I said, it could be accessible from outside the class itself. So it assigns the value of 5.5 to the object's radius member. Because radius is public, this is only allowed. Now next printing cout area is, you're going to print out the value for this. Next we are given return 0. Why do you need return 0? It's should return 0 from main, which by convention, it means the programs ran successfully. So here, the data members are public. So they can be accessed and modified directly. But this is not recommended for a sensitive data. Okay? That's why we often keep data private and make the methods public to control how the data is being used. Next, let's look about the private access specifier. When the members are declared as private, they can only be accessed by member function inside the same class. They cannot be accessed directly from outside the class. This is the default access level in C++. This is by default. Always considered as a private thing. If you don't specify any access specifier, members are automatically treated as a private. Okay, private access specifier. Private members form the core of data hiding. They protect internal data from unauthorized access and accidental modification. Let's take an example here. We start the program by including the header file, include IO stream, and using the standard namespace standard functions. Next, let's define a class named employee. Inside the class, we first have the private access specifier. Here, the data member int salary is declared as private. That means it cannot be accessed directly from outside the class. Only the member functions inside the class can access it. Now, under the public section, we have two member functions. What are they? Set salary and get salary. Yeah, set salary says that this function is used to assign a value to the private variable salary. Inside this function, we can write the salary. Right? Since we are inside the class, this is allowed. We can modify the private member very safely. Coming to get salary, this function returns the value of the private variable salary. It allows controlled access to the data from outside the class. Coming to the main function, we first create an object named emp of the type employee. Then we have given emp. What will happen? Let's also have given as an error function. What will happen when you give emp.salary? Why it will return an error function? because the salary is private here, it cannot be accessed directly from outside the class. So that's why we just have given here to make you understand that this is an error statement. Just leave that, ignore it. So instead of that, we can use the public function like set salary. So emp.set salary, you can assign the value whatever you want. Yes. Finally, we can display the salary. So this calls the get salary function, which returns the stored salary and prints it on the screen. So these provide the controlled access to the private data members. Okay, set salary and get salary. So now the output 50,000, whatever we gave here, it will be printed. 50,000 is given, so it will be printed. So in summary, I can tell that clearly shows the concept of encapsulation, which means that we hide the data salary using the private specifier and allow access only through the public functions. This ensures data security and proper control over how variables are modified or accessed. So thus the private data keeps our class very safe, secure, and logically sound. Coming to the protected access classifier, this protected access specifier. Protected members are quite similar to the private members. They are not accessible outside the class. But the key difference is that they can be accessed by the derived or also called as child classes, which is not possible by the previous type. So this becomes useful in inheritance. Now it's like, sorry. Now let's look into a small example for this. We can start the program with the header files like I was string as usual. Now let's define a class named animal, which is the parent class. Inside this class, we use the protected access specifier. We declare a string variable type and assign it the value like mammal here. Now, what does this protected means? A protected member is not accessible from outside the class, but it can be accessed by the derived or child classes. So in this case, the variable type can be accessed by any class that inherits from animal. So next, let's define a child class called dog, which publicly inherits from the animal. Inside this class, we create a public function called showType. In this function, you can print, see out whatever you want. You can print it. Here, you can see that the dog class is able to use the type variable, even though it was declared as protected in the parent class. So this shows that the protected members are accessible inside the derived class. Right? Coming to the main function, we have created an object named dog1 of type dog. Then we call dog1.show type. This will execute the function and print I'm a mammal. If we directly try to access the protected member, like dog1 type dot1 type, it leads to an error. Why it leads to a compile error? Because the protected members cannot be accessed from outside the class hierarchy. So to summarize this, we can tell that the private members are only accessible within the same class. Protected members are accessible within the class and also its derived or child classes, whereas the public members are accessible from anywhere. So this program is an example for how inheritance and protected access work together in OOPS concepts. Coming to the friend function, Already we have seen the friend function here, but let's see, let's try to link this with it. This is a very interesting and special concepts here, which has been explained here with a small example. Private and the protected members of the class cannot be accessed outside. That we know very well. But sometimes we need a non-member function to access them. For example, for operator overloading and for debugging. To allow this, C++ provides the concept of a friend function. A friend function is not part of the class, but it is granted special access to the private and the protected members. It is declared using the keyword friend inside the class. So let's code here. Let's walk through this. Here, we start by including IO stream and as usual, the namespace. Inside the, now let's define a class called my class. Inside the class, there is a private variable named secret value. Since it's private, it normally cannot be accessed from outside the class. Let's have a constructor here, that is my class. This is a constructor which initializes a secret value with the value of 10. So now comes the important part, that the friend function declaration. We declare a function called secret and make it as a friend of the class by writing the keyword friend before it. By writing the friend keyword before it. This gives the function a special permission to access the private and the protected members of the class. So outside the class, we define the function secret. It makes an object of my class as a reference. Because it's a friend, this function can directly access the private variable secret value and prints its value to the console. So here inside the function, we write cout the secret value is. Like coming to the main function, we create an object called myObject of type myClass. After this, we call the friend function secret. So when we run this program, what's the output we get here? 10. A friend function is not a member of the class, but it has access to the class private and protected members. We use it when we need certain external functions to work very closely with the internal data of the class without exposing everything publicly. Yes, that's what the function of a friend. Coming to the inline function, every time a normal function is called, some overhead is involved, like storing the return address, pushing the parameters to the stack, and jumping to the function code. This overhead can become costly for small functions that are called frequently. Very frequently, if you're calling, it leads to cost. So to avoid this, we can use the inline functions. An inline function is a function where the compiler replaces the function call with the actual code of the function during the compilation. So instead of jumping to another memory location, it just executes the function body directly, just saving time. Let's have a code walkthrough here. First, we include the header files and the namespace standard. We define an inline function called as cube. Here it's cube. So the syntax we're giving us inline int cube, and within that int of yes. This function takes one integer parameter s and returns its cube, that is s multiplied by s multiplied by s. So for example, if you pass the value of 3, cube 3, so the output will be 3 multiplied by 3 multiplied by 3, that's 27. So actually what does the keyword inline actually do here is, normally when the function is called, the control jumps to the function definition, it executes the code and then comes back. That takes a bit of extra time. So, but when a function is declared as inline, the compiler tries to replace the function call with the actual code of the function during the compilation. So this reduces the overhead of the function call, which can make the program run faster, especially for small and frequently used functions, as an example given here. That's what the purpose of this. And it's a request, it's not a command. The compiler can choose to ignore it also. So we have to define using the inline keyword. So finally, I could say that inline functions make your code very cleaner. They reduce the overhead of the function calls, but they are best used for short and simple functions. You can't use always, it's not preferable for the very bigger ones and a very complex codes. So coming to the last slide, that's private and protected difference. On the private, the class members declared as private, it could be accessed only by the functions inside the class. Whereas the protected access modifier is like that of the private access modifiers. Private members keep implementation details in a program. The protected members enhanced access for derived classes. Only the member functions or the friend functions are allowed to access the private data members of a class. Here, the class member declared as protected or inaccessible outside the class, but they can be accessed by the subclass, that's the derived class of that particular class. Private members are inherited by derived classes, but are not directly accessible in the derived classes. Protected members are inherited in the class. So main point is that when you see accessibility in the same class, yes, both are accessible. Coming to the derived class, only protected will have the access for the derived class. Coming to outside the class, both are not for this accessible to the outside the class. So the protected members are like private but inheritable members. They give flexibility in OOPS designs that use inheritance. Let's now test your understanding with the quick quiz. And you can pause the video and try to answer these questions before checking the answer that's given on the last slide. Question 1, which of the following is true about the access specifiers in C++? Which keyword allows a non-member function to access the private data of the class? Here a code snippet is given. Try to find the output. If no access specifier is mentioned in inheritance, it is by default. A friend function is declared inside the class using. Inline functions are generally defined. Yeah. You can also given a code snippet here and try to find the output for this. So similarly, you have the other 3 questions here. Protected members are accessible by. Inline functions are mainly used to. And again, a code here. Try to find out the output. So we've displayed all the output for the all the answers for all the 10 questions. Check it off. And thank you, students.